Okay, g'day all, welcome to another C++ shoot. First of all, I want to say that for all those that are waiting for the slides to be uploaded to the website, I'm really sorry about that. I don't know, completely forgot to upload all the slides, so hopefully I'll get around to uploading them shortly. But today's shoot is on using multiple headers and CPP files and class hierarchies and just basically creating multiple file projects. In C++, this is really common to separate the declarations of classes and functions from their definitions. I'm sure we've mentioned before, but usually I haven't been doing it in the shoots, so I wanted to go through exactly how it works. You don't have to do this, but it does make coding a lot easier, particularly with larger projects. Okay, so the trouble is that the simple statements split your declarations and definitions into separate headers and CPP files. That statement is easier said than done, and it's often assumed, even when you learn C++ at like a big university or whatever, it's often just assumed that once you learn about classes and headers, you'll naturally guess how to make a hierarchy of 12 classes and perfectly implement it with 24 or more files. But I tell you, this is ridiculous. We're not interested in guessing and learning from trial and error here. What we want to do is learn how this stuff works. So that's really what this shoot is about. How to make multiple file projects. What are we trying to do? We're trying to organize code so that it's reusable and easy to navigate, as well as easy to maintain. And if there's a bug in a function somewhere, we don't want to have to go through thousands of lines of code, which describe 12 different classes all mixed up together. We absolutely don't want to do that. We want classes split into separate files because it's easy to find things and easy to fix things. And if you define the same symbol twice in the same file or a separate file, your program's not going to compile. And this can lead to a confusing and extremely time-consuming tangle of duplicate symbol errors. And many, many frustrating hours of trying to pragma once them to oblivion. Like my use of pragma once as a verb there. But you'll want to avoid these duplicate symbol errors that come up again and again when you're first learning about headers and defining classes in separate files. Okay, so that's pretty much what this shoot is. We're going to scream through the slides and get to a coding example at the end that I hope should be really helpful. But the basic pattern is that we want to declare a class in a header with the same name as the class, and declare function prototypes and class specifications in that header. But then we want to actually define the member methods in a separate C++ file, so CPP file. The CPP file will also have the same name as the class, usually. All of these things are conventions, you don't have to do it like this. But it's a good idea, at first at least, until you feel comfortable with this. Other classes can include the header in their own header, wherever symbols are required. If you need a symbol from a particular class, or if you need a symbol from some particular header in your header or in your CPP file, then you're going to have to include it at some point. But we'll have a look at how all that works. Alright, so a couple of notes about including headers in CPP files. If you've got a CPP file that includes a header j.h and j.h includes p.h, then the CPP file also includes p.h. I hope that makes sense. So you can sort of follow a trail of headers and figure out exactly which headers your CPP file is including. You can include p.h either in your CPP file or the header to your CPP file, or both if you like. We'll see there's a few different ways to do this, but often you'll include your headers in the headers to your class. I hope that makes sense. Don't make circular references in headers either. That's not a good idea. Alrighty, so guards. We've got to talk about guards first. Guards for headers are primarily used to prevent a header from being included more than once. They're just used to ensure that whatever symbols are declared in a header are declared only once. So we want to avoid declaring duplicate symbols because that'll obviously produce errors. And to prevent the compiler from duplicating headers everywhere, we use what's called a guard. So there's two common syntaxes for guards. The first way, and the proper way to do it, the universal method, which is common to all C++ compilers, is to use define, to define a symbol. Preprocessor symbol. If ndef, or if not defined, that stands for. Remember the pound or the hash at the start, and then header name underscore h. You can call this define whatever you want. I tend to use whatever my header's name is and then underscore h. Then define whatever that symbol is. Then you place your code. Then you've got ndif down the bottom. So if the compiler has read the define header.h line at some point in the past during its compilation, it's going to skip defining the code again. I hope that makes a bit of sense. And header name is whatever your header is. So if you're defining lion.h or whatever, then your if ndef would read if ndef lion underscore h define lion underscore h. Okay, but the easier way to do it, and this is really, really common, so common that I think just about every C++ compiler supports it, but it's not C++ standard. The easier way is just to use your hash pragma once. Yeah, so same thing. It's just a guard. Okay, that's good. So there's a couple of different ways to understand how to implement a class hierarchy with headers and CPP files. The number one is probably have a go yourself, but don't spend too much time having a go yourself because it's largely trial and error. What you really want to do is study code that does this and have a look at how other people do it. So the next slide contains a bit of a challenge, and have a go if you want. Otherwise I'm going to do it myself in a moment and you'll see at least one way to do it. Okay, so here it is. I'll just hit escape. There it is. So have a go at that if you like. Just a couple of little steps there, creating a little class hierarchy and using it with a main method. And if I come over here to C++, alright, I'll get started. Where are we? Okay, so the first objective, create a main.cpp file with a main method. Well, that's easy enough. If we just right click on the project's name and we come down here to add new item and main.cpp. Okay, so I'm going to include IO stream because I know it's going to be used later. Name space. Learn how to spell. What's happened to my keyboard? That was my keyboard doing that, not me. Okay, but I typed all this really cool stuff down here that worked. Alrighty. Okay, so that was easy enough. Create a main file with a main method. Okay, point number 2. Create an abstract parent class called shape with a purely virtual method area and perimeter. Okay, so we want to use our multiple files in this project since that's what the whole shoot's about. So we're going to want to define this, we're going to want to declare the shape class in its own header. So what we do is we right click on our project name, we say add a new item, we select header, and the class that we're declaring here is called shape, so that's the name of our header, shape.h, and we hit enter. Okay, here we are in shape.h, and what we want to do here is first of all add a guard so that we can't accidentally include shape.h more than once. So if ndef shape underscore h, or if not defined, shape underscore h, define that symbol, and at the end we put the ndif, or you can put here ndif shape underscore h, just to make things a little bit more explicit. So that's the end of the if block here for the compiler. Okay, so the class that we're making is called shape, and it's got a public method called area, and it's got a public method called, I didn't say it was public in the little write up there, but it's meant to be public, so perimeter. Alrighty, so far so good. We've got a class called shape in its own little header, but we do have a bit more to do. So make the class abstract and make these methods purely virtual methods. So how do we do that? Well, if you've not looked at last shoot, I think you should go back and have a bit of a look at that, because that's how you do this. What we want to do is mark the two functions as virtual to mean that any child classes that derive from this are free to override these functions. But the other thing, to make it purely virtual, we say equals 0 straight after their declaration. And that not only makes these methods just here purely virtual or abstract methods, but it also makes the enclosing type abstract. Okay, so the shape class is now abstract. Alright, so the next point, create a derived class called circle in a file called circle.h. Okay, so let's make a new file called circle.h. Add new item, and it's a header. And the class that we're making is called circle, so we better put this in a file called circle.h. Okay, so for this file here, I might just pragma once, which is exactly the same. Remember, that's exactly the same as if and def and define and this one down here. But it's a bit quicker. Okay, so class circle, and I might just make public as well. Okay, so there's my circle class. What do we have to do? Make a derived class called circle in a file called circle.h. The parent is the shape class. Okay, so the parent is this shape class that we just defined before, which means that we're going to want something like this. But there's a problem. At the moment there's a problem. So shape is underlined. And it's underlined because the circle.h header doesn't know anything about the shape header. So how do we fix that? Well, we include shape.h in the circle class. Hey presto. Alright, so at the moment the circle class is publicly inheriting from the shape class, but the shape class itself is abstract, and since the circle class doesn't presently override these area and perimeter methods, the circle class is abstract at the moment as well. But give the circle class a protected radius as a float, which is set in the constructor. So we might make protected float radius. And here's my constructor, circle, and takes a float. I might just say r, and radius r. Okay, so that's the constructor, which is going to set the radius to whatever the parameter I pass is. But I did want to mention that it's really common if you've got something very simple like this constructor just here, which does nothing more than set a single float. It's common to implement the code to that in your header. Yeah, but other than that, if you've got complex methods or methods that require more than one line, you usually don't want to implement them in your header. What you want to do is implement them in your CPP file, which is what we're just about to do. Okay, so define the abstract methods in circle.cpp. Okay, so we want to define the body to the methods area and perimeter for our circle class in the circle's CPP file. Okay, so circle doesn't have a CPP file at the moment, so we might just add one. Add new item. And the class that we're defining is the circle class, so we'll call our file circle.cpp. Okay, so the first thing that you've got to do in your implementation file or your code file for a class is include the header for the class that you're defining, circle. And the methods are circle area. And the area of a circle is, what is it? It's, what's it? 3.14 f times radius, times radius. Yeah, so that's meant to be pi. It's obviously not really pi, but it's close enough. So pi r squared is going to give you the area of a circle. And why is that underlined? Inherited member is not allowed. Okay, so now we've got a bit of a problem. So what we want to do to fix that problem there is specify in the circle.h header that we're overriding that method. Yeah, I forgot that. Sorry about that. So area, and we're overriding it. Yeah, and float perimeter, and we're overriding. Yeah, so that should fix up that. You don't actually have to have override there, but I think it's a good idea, like I mentioned last shoot. Alright, so floats and circle, and the other one that we've got to do is the perimeter, or the circumference of the circle. So the circumference of a circle is, what is it, like 2 pi r? Yeah, I think that's it, 2.0 times 3.14 f times radius. Okay, so there we go. We've completely defined a circle class which inherits from the shape class, and we've used a good bunch of headers, and we've included them in such a way that we're not going to run into any duplicate symbol problems. Alright, on to the next question. Create a derived rectangle class with shape as its parent. Okay, so this is similar to the previous question. We want to create a rectangle class, so we'll go new item. We're going to want to declare it in a header, so we select H or header, and the class that we're declaring is called rectangle, so we might as well call this file rectangle.h. And at the top I'm going to pragma once, so it doesn't get included more than once, and we'll class rectangle, and we'll publicly inherit from the shape parent, and we'll public there as well. Okay, so once again in the rectangle class you're going to want to include the parent's header, which is shape.h. Okay, so that's good. Create a derived rectangle class with shape as its parent. Give the class protected width and length as floats and set them in a constructor. Okay, so we want protected float width and height. And we want to set them in a constructor, so rectangle, I might just say W and float H, and width and height. Oops. Yeah, there we go. So a quick way just to set parameters is to use this syntax here outside of the body of your method. If you like, you could just as easy do the setting of the width to W and height inside the body of your method, like the like this. Yeah, that would be fine as well, but yeah, this way here might be a bit quicker. You'll see that again and again too in the code that we look at in the future. Okay, so that's pretty good. Define the area and perimeter methods in rectangle.cpp. Okay, so we're asked now to define the area and perimeter methods, but I'm not going to forget again, first thing that we've got to do is specify that we intend to override those purely virtual methods from our parent class. So area and override and float perimeter and override. Okay, simple as that. Now if I right click over here, we're going to add an implementation file to this class, but what we're going to do is select CPP, so this is implementing the actual bodies to these functions, so we want a CPP file, and the class that we're talking about is the rectangle class, so we want rectangle.cpp. It's that easy really. And you don't have to pragma once, but what you do have to do is include, well, yeah, include the rectangle file. Rectangle.h, the rectangle header. And what I do want to mention also is that the rectangle header itself includes the shape header, so rectangle.cpp is actually including the shape header as well. Yeah. Anyway, float rectangle area, and to calculate the area of a rectangle we return, what is it, width by height. Should do the trick. And float rectangle perimeter, and the perimeter of a rectangle is 2 by height plus width. Now I better put those in brackets so that the multiplication doesn't happen first. Alrighty, so there we've got two inherited classes, rectangle and circle, and we've got a parent shape class. Okay, all good. Now things get a little bit tricky down here. So create a square class with rectangle as its parent. So not shape as its parent, but rectangle as its parent. And declare it in a file called square.h. Alrighty. If I right click, add new item, a header, and square. Okay, so I might, if and def, I might do the long way for no particular reason. And if. You always want to make sure that the if, and def, and define are exactly the same symbol name, otherwise you're going to run into trouble. So I'll often copy them and paste them just to make sure that they are the same symbol name. Okay, so class rectangle, no, class square, and it inherits publicly from a rectangle. Rectangle. Okay, so for the square we don't need to include the shape header, because the square actually inherits from the rectangle class. So what we do want to include is the rectangle header. Yeah, and the rectangle header itself happens to include the shape, but from the square header we don't really care. Okay, but that lets us define a class with rectangle as its parent. What was the next bit? Declaring it in a file called square.h. Give the square sidelen as a float and set it by calling the parent constructor. Give the square sidelen as a float. Okay, the rectangle parent class actually has width and height, and a square is a rectangle except width and height are equal. So what I might do is this rectangle. Yeah, so my constructor for the square now sets the width and height to exactly the same number, this sidelen parameter, by calling the parent's constructor, yeah, with the same value for width and height. Okay, so that should do that just about. Add a diagonal method which calculates the distance from opposite corners. Okay, to square.cpp. Alright, so before we do that, I want to mention that square inherits from rectangle. And rectangle is not an abstract class. Rectangle implements the perimeter and the area already, so we don't have to change those at all. Square doesn't need to implement those at all. But it does need to implement diagonal, so if we float diagonal, just like that. So we declare that the square is able to call a function called diagonal in the square's header, but we don't implement it there because it's a code. We implement the body to the function, I should say, in square.cpp. So we add square.cpp and we include square.h, and we float and square and diagonal. Okay, and I'm not real sure how intuitive it was to read what I was asking you to do there, but what I'm trying to get you to do is return the length from one corner to the opposite corner of a square. So the diagonal is width by the square root of 2.0. Yeah, width by the square root of 2.0, or height by the square root of 2.0. It doesn't really make a difference. And the actual formulas here aren't what's important, but it is underlining square root, so I might actually also include in the square code file cmath.h. Yeah, so you can include other things in your implementation or your CPP file that your header doesn't necessarily include. Or, we could include cmath here if you like. Yeah, it's up to you. I tend to include it only in the files where it's actually used. So square root needs this cmath header, that's why I've included it in the square.h. Sorry, the square.cpp file. Calculates the distance from opposite corners. Okay, so we've done that. Now the final thing is we want to create instances of these classes in our main file and call those methods to see what happens. Okay, so the first thing that we want to do is include the headers for the shapes that we're going to be using in our main.cpp file. So this is perfectly fine. It's not going to lead to duplicate symbols because they're all pragma onced, or they've all got guards about them. I might just put in cin.get down here instead of getch. A couple of people complaining about my use of getch. Good on yous, really. Yous are right. Yous are 100% right. Okay, so circle. We want to define a circle. I'll say circle. Circle C, and I might say 13 is the radius of the circle. I might say rectangle R, and I might set it to 3 and 5, and finally I'll make a square called S, which will have a side length of 7. Just because I'm such a big fan of prime numbers, 7, 3, 5, 13. Now, we want to call all of those methods that we defined. and hopefully everything will go well. We'll have a bit of a look. So see out. I might see out the circle first. Circle, handle, and see out. We'll say area, and c dot area, handle, and see out perimeter, perim, and c dot perimeter, handle, and I might see out an extra handle at the end. Okay, so that's calling the two circle methods, area and perimeter. Next we'll call the rectangle one. So rectangle, and that's called R and R. And that should do it for the rectangle, and we'll copy and paste that for the square as well. So square and S and S. So the square not only had area and perimeter, but it also had diagonal. So we better put that at the end. Diag on all. S dot diagonal. And we cross our fingers, we hit F5, and what do we got? We've got exactly what we're after. How wonderful for us. Okay, so I hope that gives you a bit of an idea of how to implement a class hierarchy using more than one file. And I hope you can see from that too that it would be very easy now to, say, edit the rectangle class. You know, it's really easy to find the code for that, or to track down bugs in the circle class, and yeah, generally splitting your larger projects anyway up into separate files is a super good idea. Thanks for watching all. See you later.